So we are finally to the last video for this Module 1A, and we're going to talk about the idea that velocity is relative, and we're just going to work through this example and discuss it as we go through. But I'll read the example problem to you. It says that a car and a truck are approaching each other on a two-lane road. The speedometer in the car reads 56 miles per hour, and the speedometer in the truck reads 45 miles per hour. If you were standing at the side of the road watching this situation, what velocity would you observe for the car? What velocity would you observe for the truck? And what velocity does the driver of the car observe for the truck? And what velocity does the driver of the truck observe for the car? And I have in this box our basic equation, that the velocity of object A relative to object B equals object A's velocity minus object B's velocity. Okay? I'm going to write that up here at the top of our page, actually. We have the velocity of A relative to B equals the velocity of A minus the velocity of B. All right, and I've already drawn a little picture of our situation. So maybe you can see this here. We have our car traveling 56 miles per hour to the right, and our truck traveling on the other lane in the opposite direction, 45 miles per hour. And here you are standing on the side of the road. For this problem, we're going to define positive to be to the right and negative to the left. Again, we're working in one-dimensional motion. So the beginning parts of this question ask, what velocity do you observe for the car? Okay, so let's look at our formula again. The velocity of A relative to B. So what velocity are you perceiving the car relative to you? So in this situation, we're looking for the car's velocity relative to you standing on the side of the road. Okay? So it's going to be the velocity of the car minus your velocity. So in order to figure out what the car's velocity is relative to you, it's the car's velocity minus your velocity, which in the end is going to be 56 miles per hour. When we take a look at the truck, he's going in the opposite direction, right? So here you are on the side of the road looking at the truck. The truck's velocity for you on the side of the road is going to be a negative 45 miles per hour. Remember, that truck's going in the opposite direction minus your velocity. So in all, it will be negative 45 miles per hour. Now the next part of the problem asks, what does the driver of the car observe of the truck? So again, the velocity of A relative to B equals VA minus VB. So we have to figure out which is A and which is B. So what does the driver of the car observe of the truck? VA relative to VB equals VA minus VB. So the truck relative to the car is going to be the velocity of the truck minus the velocity of the car. So we have a negative 45 miles per hour minus zero, I'm sorry, not zero. It's going to be a negative 45 miles per hour minus 56 miles per hour. The velocity of the truck was inherently negative, minus the positive velocity of the car. So the velocity of the truck relative to the car is going to be negative 101 miles per hour. And similarly, if we take a look to figure out what the velocity of the car is relative to the truck, so we're in the truck watching the car. We're going to have the velocity of the car minus the velocity of the truck. So our 56 miles per hour minus our truck's velocity, which is a negative 45 miles per hour. This ends up being a positive 101 miles per hour. So the relative velocity of the truck to the car, so the car driving 56 miles per hour this way is going to perceive the truck driving 101 miles per hour towards them. And the car relative to the truck, the person in the truck is also going to perceive them coming at them 101 miles per hour, but because we defined to the right to be positive and to the left to be negative, it's going to be a positive 101 miles per hour.